Hey everyone, and welcome to this explainer. Look, if you're staring down Class 9 Geography Chapter 4 on climate and feeling, well, entirely overwhelmed, take a deep breath. Seriously, you are not alone. This chapter has a notorious reputation for confusing students. But here's a little secret. It looks way tougher than it actually is. I'm going to be your supportive study buddy today. We're going to strip away all that confusion, rely on a really clear visual structure, and build a crystal clear roadmap that is going to make your exam prep an absolute breeze. Let's do this.
Okay, let's dive into this. To completely master the syllabus, we've broken the chapter down into 5 essential pillars. 1. Weather versus climate basics. 2. Regional temperature variations. 3. Core climate control factors. 4. India's monsoon mechanics. And 5. Monsoon seasonal patterns. All right, starting right off with Section 1, Weather versus Climate Basics.
Let's clear up a distinction that is a guaranteed exam question, short-term versus long-term. Weather, that's the atmospheric state at a very specific point in time. Imagine you're standing outside in the hot sun sweating. Well, that's the weather right now, but suddenly it starts pouring rain. Boom, the weather just changed. Climate, on the other hand, is the long-term average over a massive area. For example, India experiences intense heat, freezing winters, and heavy rains. But because this specific cycle of conditions repeats consistently, year after year, over a huge period of time, we define India's overall climate as a monsoon-type climate. Makes sense, right?
Moving right along to Section 2, Regional Temperature Variations.
Fun fact for you, the word monsoon actually comes from the Arabic word mausium, which literally translates to season. And across India, these seasons bring some wild extremes. Let's do a few rapid-fire facts you can use on your exam. In the summer, the deserts of Rajasthan hit a blistering 50 degrees Celsius, while up in Jammu and Kashmir, it's sitting at a very comfortable 20. In winter, Dras in Jammu and Kashmir plummets to a bone-chilling minus 45 degrees. Meanwhile, down on the coast in Thiruvananthapuram, they're enjoying a mild 22. We also see huge variations in rainfall. Meghalaya gets absolutely soaked with 400 centimeters of rain, while the northwest gets barely a drop. As a general rule of thumb to remember, coastal areas have moderate climates, while the interior faces extreme shifts.
Next up, Section 3, Core Climate Control Factors. So what's actually causing all these massive variations? We need to zoom out for a second and look at the macro level. There are 6 universal rules, or controls, that dictate the climate of literally any place on Earth. First is latitude. The closer you are to the equator, the hotter it is. Second is altitude. The higher you go, like up a mountain, the colder it gets. Third is pressure and wind systems, which essentially just move air and moisture around. Fourth is distance from the sea. Coastal areas have stable temperatures, while places far inland suffer extreme heat and cold, a concept known as continentality. Fifth are ocean currents, which warm or cool the air directly above them. And finally, relief features. Think mountains here, which can physically block winds and dictate exactly where rain falls. Now, let's bring those global rules back home to India. Starting with latitude, the Tropic of Cancer cuts right through the middle of the country. This means the southern half is in the tropical zone, so hotter year-round, while the northern half is subtropical. For altitude and relief, we have the towering Himalayas up in the north. They act as this massive physical shield, completely blocking freezing cold winds from blowing in from Central Asia. Honestly, without the Himalayas, the Indian subcontinent would be freezing.
Okay, grab your pens, because this brings us to a massive high-yield exam term, the Coriolis force. Because our Earth is constantly spinning, winds don't just travel in a straight, boring line. They get to fleck it. In the northern hemisphere, where India is, they always curve to the right. Without this crucial force, the distinct northeast and southwest wind patterns that create India's specific climate simply wouldn't exist. It's a real game changer. Then we've got the jet streams. Think of these as powerful, narrow rivers of westerly air flowing high up in the troposphere. The crucial point for your exam is how they migrate. During winter, they sit south of the Himalayas, occasionally bringing some light winter rain. But as summer arrives, they shift north of the Himalayas. That shift is absolutely essential because it makes room for the monsoon to arrive.
Which brings us to the main event, Section 4, India's monsoon mechanics. How does all this rain actually get pulled into India? Well, it all starts with the ITCZ, or the Intertropical Convergence Zone.
I want you to think of this as a massive low-pressure heat vacuum. Because land heats up way faster than water, during the intense Indian summer, a huge low-pressure zone forms over the interior of Asia and India. The ITCZ literally shifts northward away from the equator and rests right over the Ganga Plains. This intense low pressure acts exactly like a giant vacuum, sucking the moisture-heavy winds straight in from the high-pressure Indian Ocean. But nature isn't always perfectly predictable. You absolutely need to know about El Niño for your test. Usually, there's high pressure in the Pacific Ocean and low pressure in the Indian Ocean, which pushes all that great rain toward India. But during an El Niño year, the tropical Pacific mysteriously warms up, and those pressure zones actually reverse. When this happens, the monsoon winds get weakened or delayed, which results in significantly less rainfall for India. Now, assuming it's a normal year, the advancing monsoon hits the southern tip of India and literally splits into two branches. Branch 1, the Arabian Sea branch, smashes into Mumbai around June 10th and pushes up towards Saurashtra and Kutch. Branch 2, the Bay of Bengal branch, sweeps up into Assam. But remember those relief features we talked about? The high mountains in the east block the clouds, deflecting this branch westward over the Ganga Plains. By late June, these two branches finally reunite over northern India, bringing massive, widespread rain. And finally, Section 5, Monsoon Seasonal Patterns. The terminology around India's seasons can get a little confusing, so let's build a chronological mental timeline to help you recall this during the exam. The year kicks off with the cold weather season from mid-November to February. That's marked by cold, dry winds from the north. Then, from March to May, the heat really builds up in the hot weather season. June to September is the main event, the advancing monsoon, where those southwest winds bring massive rainfall. Finally, October to November is the retreating monsoon, where the rain clouds withdraw back down the country. During that hot weather season, right before the monsoon breaks, there are a few specific local phenomena you've just got to memorize. First up, the Lu. These are strong, incredibly hot, and dry winds blowing across north and northwest India during the day. Next is Kal Baisakhi. Fierce, totally destructive thunderstorms that strike West Bengal. And finally, mango showers. These are really welcome pre-monsoon rains down in Kerala and Karnataka that famously help the local mangoes ripen early. And what happens when the monsoon finally packs up and leaves? We get hit with something called October heat. As the monsoon retreats during October and November, the clouds clear up and the sun beats down on land that is still completely soaked with moisture. The result? A massive spike in temperature combined with extreme, practically suffocating humidity. It's a uniquely uncomfortable transitional phase right before the cool winter officially sets in. Well, we've covered a lot of technical ground today, from the Coriolis force to pressure zones, but I want to leave you with a final thought to ponder, beyond just the exam facts. We just saw how India has 50-degree deserts and minus 45-degree mountains, yet the entire landscape, the massive agricultural cycles, and almost all cultural festivals revolve entirely around the arrival and departure of these monsoon winds. It is literally the rhythmic heartbeat of the country. So ask yourself, despite all these extreme geographical differences, isn't it incredible how the monsoon acts as the ultimate unifying bond for the entire Indian subcontinent? Keep that in mind as you review your notes. You've totally got this. Thanks for joining me on this explainer, and happy studying!